Good evening. The aim of this video to explain Ohm's law for the resistor. For this purpose, we make the following circuit. In this circuit, we use the resistor itself, the source of electricity, a battery or generator. We can change the voltage of this generator. We need a meter to measure the current. We need a voltmeter to measure the voltage across the resistor and a switch. Setup, we connect the following circuit: the battery, the resistor, and the ammeter and the switch are in series. And we need a connecting wire to complete this circuit. The circuit is completed. The voltmeter is connected across the resistor to measure its potential difference or its voltage. The circuit is completed. The third setup, experimental setup, is the observation. What do you observe? We observe the current is zero since no current in the circuit is open. The voltage also equal to zero since no potential difference or no voltage across the resistor. This is the first observation, the first value. 0 for the current, 0 for the voltage. We close the switch. The current, the voltage 2 volt, the current 100 milliampere or 0.1 ampere. We change the voltage 4 volt, for example. We obtain the current 200 milliampere or 0.2. So we observe as the voltage increase, the current increase. To improve or to deep this observation, we change the voltage another time. For example, 6 volt. 6 volt, we obtain a 300 milliampere or 0.3 milliampere. So the observation is, as the voltage increase, the current increase. We put the obtained value in the following table. In this table, for example, this table, the voltage U2, 4, then 6, the obtained current 0.1, 0.2, and 0.3. We calculate the ratio U over I. We observe, in the first case 20, in the second case same value, in the third case same value. So the voltage U relative to the current I, the ratio of U over I in this case remains constant. What is the physical meaning of this constant? We make a chart, a graph. We draw the variation of the voltage U as the y-axis, the function, with respect to the current as the x-axis. We obtain the following chart, the following graph. This is the graph. This is an important graph. All dots, all value are collinear. So the variation of the voltage as a function of the current is a straight line and passing through the origin. And the straight line is an increasing straight line. So it has a positive slope. 3 important conclusions. The variation of the voltage with respect to the current is a straight line passing through the origin and has a positive slope. Finally, Ohm's law for the resistor. Ohm's law for the resistor. We obtain straight line has a positive slope and passing through the origin. The equation of a straight line is y equal Y equal AX plus B. But B equal to 0 in this case, because the straight line passing through the origin. Y equal AX. Y is the voltage U, equal X is the current I, and A is a constant, is represented by R. R is the ratio U over I, is the resistance, of the resistor. Each resistor is characterized by its resistance R. Therefore, Ohm's law, U equal R times I, or the voltage across the resistor, is directly proportional to the current through it. So as the current increase, the voltage increase in the same rate. This is Ohm's law for the resistor, U equal R times I, or I equal U over R, or R equal U over I. The voltage across the resistor is directly proportional to the current passing through it. This is Ohm's law for the resistor.